The word spread through the American camps like a brush fire that summer of '44. The Germans possessed something new, something terrifying. A steel colossus that weighed 70 tons. Armor plating so thick it would shrug off everything the Allies threw at it. And a gun with reach that extended beyond 2 kilometers. A gun that could annihilate anything the Allies had. The military intelligence people gave it a name: the King Tiger. Over in Germany, the crews who would man these machines had another name for it: unbeatable. To the American tankers who heard the stories, it was pure dread. The British were the first to encounter it. Around Caen in Normandy, July 11, 1944, when the 503rd Heavy Panzer Battalion rolled out the King Tigers for the first time. What came back were descriptions that seemed pulled from nightmares. Tanks bigger than anything anyone had ever seen. Shells that bounced off their front like they were made of rubber. And from distances where the British guns could barely reach back, the impact was instant and crushing. Fear rippled through the ranks. Intelligence officers in the American command started gathering reports. From the British Second Army, who were doing the fighting. From Soviet military intelligence, who said these machines were already chewing up the Eastern Front in August. From French resistance networks, who spotted enormous tanks being moved by rail through occupied territory. Every source told the same story. Germany had built something unprecedented, something that outmatched every single tank the Allies possessed. Everyone had heard whispers about this mechanical nightmare for months. Now it was real. British units in Normandy confirmed it. The Soviets confirmed it from their own battlefields. And every Allied tank crew memorized the specifications like a prayer they hoped would protect them. 180 millimeters of armor on the turret alone. An 88mm gun with a barrel stretching over 6 meters. A combat weight that dwarfed anything else on the battlefield. This was not another tank rolled off some factory line. This was Germany's solution. Their answer to American and British numerical superiority, a machine built to restore German dominance, to turn the tide. Tank crews sat through intelligence briefings that seemed designed to break their spirits. The King Tiger weighed 69.8 tons, more than double a Sherman. Its 88mm KWK-43 gun could punch through 150mm of armor from 2,000 meters away. The sloped front armor, 180mm on the turret, 150 on the hull, could stop virtually every anti-tank weapon the Allies had in service. The fear that settled over the crews was justified. American tankers had gotten used to fighting Panzer IVs, even the nasty Panthers. But this was something else entirely. Something worse. According to the briefings, a King Tiger could penetrate a Sherman's front armor from distances where the Sherman couldn't shoot back. It would take 4, maybe 5 Shermans flanking and working together to bring down one King Tiger. And they would take terrible losses doing it. The men stopped sleeping well. Tank commanders swapped stories picked up from British crews. Officers who had watched their shells ricochet harmlessly off King Tiger armor from 800 meters. Men who described a single King Tiger destroying 3 Churchill tanks one after another before simply turning and leaving, barely scratched. These stories spread through the armored units like a plague, building up this legend of invincibility around Germany's newest weapon. And the fear was not crazy. It was mathematical. In a straight fight, the King Tiger won. Every time. A Sherman 75mm gun could not penetrate that frontal armor. Not at any range where a tank realistically fought. Even the newer Shermans with the 76mm gun struggled against those thick sloped plates. British 17-pound guns had a better chance, but only if they got a good angle, and only at closer range. Which meant the King Tiger got the first shot. And with a gun like that, first shot usually meant last shot. Back in early July, elements of the elite Panzer-Lehr Division got their allocation, 5 King Tigers for Normandy, the cutting edge of German tank warfare. Each one cost 321,500 Reichsmarks, 3 smaller German tanks for the price of 1 King Tiger. 3 Panthers could have rolled off the assembly line instead. These were not mass-produced. These were hand-built precision instruments. German engineering at its finest. delivered at a moment when Germany desperately needed something, anything, that would turn the war around. Those 5 King Tigers carried weight beyond the battlefield. Albert Speer, Germany's armaments minister, had promised more. Promised hundreds. The Henschel factory and others were working around the clock. But production moved at a crawl. Skilled workers were nearly impossible to find. Allied bombing kept disrupting the supply chains. Tungsten, molybdenum, materials critical for armor-piercing ammunition and armor plates. Getting them became harder every month. Each King Tiger that actually rolled off the line represented something close to a miracle. A triumph of German industry refusing to surrender despite impossible circumstances. The men chosen to crew these machines were pulled from the Eastern Front. Veterans, survivors of Kursk, men who had fought their way out of Soviet encirclements that would have destroyed lesser soldiers, pulled from the desperate grinding war in the East and reassigned to form the core of the 316 remote-control Panzer Company attached to Panzer-Lehr. Their confidence bordered on absolute. They understood what German armor could do. They had watched Tigers tear through Soviet T-34 formations. They had seen what was possible. Now they would show the Americans and British what true tank warfare looked like. These were professionals. They knew how to position vehicles for maximum advantage. They understood terrain. They knew sightlines. How to create kill zones where enemy tanks would be destroyed before closing to effective range. In inferior vehicles, they had proven dangerous. In King Tigers, they expected dominance. Then they saw the machines themselves. These hardened veterans felt something shift inside them. The King Tiger simply dwarfed everything around it. 3 meters tall, over 10 meters long, with the gun extended. 69.8 tons fully loaded. It dominated the landscape with sheer presence. The frontal armor sloped at angles that would deflect shells like they were bouncing off water. That magnificent 88-centimeter gun. That promised destruction to anything within its reach. This was not simply a tank. This was a fortress on treads, a weapon that would change everything. The crews familiarized themselves with their new machines, learning the King Tiger's peculiarities. The steering required real effort. The transmission demanded respect. Careful shifting or risk destroying it. The fuel consumption was staggering. 190 gallons to travel 120 kilometers on good roads. Off-road, the number got worse, but trade-offs seemed reasonable. The combat power the King Tiger provided was overwhelming. Mid-July brought orders. The King Tigers were moving, from their assembly area to the front lines, to Tilly and Saint-Lô, roughly 80 kilometers through the French countryside. The crews performed their pre-combat checks with the precision they had learned through hard experience. Oil levels, track tension, fuel, ammunition, every system verified, double-checked, certified, ready. The mechanics signed off. The company commander reviewed the logs. Perfect, brand new machines. Fresh from Henschel, built with the finest German engineering available. What could possibly go wrong? The first King Tiger's Maybach engine roared to life, all 700 horsepower straining to move 70 tons of steel. The driver engaged the transmission and felt the tank surge forward toward the front. Behind him, 4 more King Tigers followed. Commanders standing proud in their turrets, crews eager to prove German superiority. Then barely 10 kilometers into the journey, the first tank stopped moving. The lead machine's transmission began producing sounds no mechanic wants to hear. Metal grinding against metal. The driver tried compensating, shifted carefully, reduced speed. Nothing helped. The gearbox, already stressed beyond its design limits by the weight pressing down on it, simply failed. Within minutes, the King Tiger sat motionless on a rural French road. The entire column blocked behind it. The crew dismounted in disbelief. This could not be happening. Not now, not to Germany's most advanced tank. The commander ordered repairs. The mechanics delivered bad news within minutes. The transmission was finished. The internal gears had stripped completely. The tank needed to be towed back for a complete gearbox replacement. Getting it off that road required another King Tiger or a massive recovery vehicle. Neither was available. The Maybach transmission in the King Tiger was fundamentally the same design used in the 45-ton Panther. German engineers had not significantly strengthened the gearbox to handle an additional 25 tons of weight. Under the strain of moving 70 tons, gear teeth stripped, bearings failed, synchronizers wore out rapidly. This was not an isolated manufacturing defect. It was a systemic design flaw. One down, 4 tanks remaining. The column reorganized and pressed forward. Surely this was an anomaly. Bad luck, bad manufacturing. The war had to be won. Every hour mattered. American and British forces kept grinding forward. The remaining 4 King Tigers continued their journey. Their commanders slightly less confident now, but still determined to reach the front. 15 kilometers further, the second tank's engine began struggling. The Maybach engine, perfectly adequate for the 45-ton Panther, was desperately underpowered for 70 tons. The power-to-weight ratio was barely 10 horsepower per ton, nowhere near adequate for sustained operations. As the King Tiger climbed a modest hill, engine temperatures started climbing. The cooling system, already marginal in its design, could not cope with the heat an engine generated running at maximum output just to maintain basic speed. The driver watched his temperature gauges creep into the red zone and reported the problem. They reduced speed, hoping the engine would cool. It made no difference. The coolant was boiling. Steam vented from the engine compartment. Within minutes, the overheated engine seized. The pistons expanded inside their cylinders until they could not move. The tank coasted to a stop. Smoke rising from the engine deck. German engineers had recognized the power deficit early during development. The upgraded Maybach 234 with fuel injection produced 800 horsepower. But production delays meant most King Tigers received the inadequate HL 230. The result was entirely predictable. Extended operations at high power output generated excessive heat that overwhelmed the cooling system and triggered cascading failures. 2 down, 3 tanks left. Now the pattern became undeniable. Panic started creeping into the remaining crews. These were not random incidents. These were systematic failures. The King Tiger, for all its impressive armor and devastating firepower, had a fatal weakness. It was too heavy for its own drivetrain. The engine, transmission, and cooling system were all operating beyond what they were designed to handle. What looked invincible on the test range became a burden on campaign. The third tank managed another 20 kilometers before its final drive failed. The massive gears connecting transmission to drive sprockets could not handle the torque required to move 70 tons across rough terrain. The teeth stripped. The drivetrain seized. The tank stopped, its crew staring at each other with growing horror. Final drive problems would plague King Tigers throughout their entire service life. A report from the Schwere Panzerabteilung 506 in September 1944 documented the disaster in exact detail. 12 final drive housings failed after only 50 to 100 kilometers of operation. Sprocket teeth sheared off under load. Track tension devices broke repeatedly. The battalion commander requested urgent meetings with armaments officials to address the catastrophic failure rate. 3 down, 2 remaining. At this point, the company commander faced a dire predicament. Of the 5 King Tigers that had rolled out that morning, just 2 were still running, and neither had even arrived at the fighting. They hadn't fired a single round in anger. They hadn't encountered one enemy tank. They had simply attempted to cover 80 kilometers on their own power. Roads and 60% of the entire force had fallen apart mechanically. The commander had no choice. He ordered the 2 surviving tanks to move forward slowly, coaxing their exhausted engines, hoping desperately that the transmissions could hold together long enough to reach German positions. Behind him sat 3 of Germany's most advanced fighting machines, stopped dead not by enemy weapons, but by flaws in their own design. The 4th King Tiger quit 30 kilometers short of the front. The suspension gave way. Those overlapping wheels designed to spread the massive tank's tremendous weight across the ground proved vulnerable to damage when pushed this hard. A bearing in one of those wheels seized up solid. The wheel locked completely. The track came free from the sprocket. The machine shuddered to a stop, tilted awkwardly to one side, utterly stuck. 4 tanks destroyed, 1 was left. Just a single King Tiger from those original 5 actually made it to German defensive lines near Tilly. 1 from 5, that's 20%. 2 out of 10 would fail before ever seeing combat. The men inside that lone survivor looked back at the trail of crippled metal behind them and faced a hard truth. Germany's wonder weapon wasn't wonderful at all. It was overbuilt, never tested under real conditions, and deeply broken from the ground up. Yet the account doesn't finish there. What happened to these 5 King Tigers followed a pattern that would keep repeating across different regions. These specific machines, numbered 28,001 through 28,005, belonged among the earliest King Tigers ever built. They rolled off assembly lines in March 1944, carrying early Porsche turrets. Command had sent them to the 316 radio-controlled Panzer Company, a unit specializing in remote-operated demolition machines launched from Tiger tanks. Their planned mission was destroying fortified positions through wireless-controlled explosive packages. When this unit moved to Normandy in June 1944, those 5 King Tigers stayed behind at Châteaudun, roughly 200 kilometers away from the fighting. They were deemed too temperamental for actual combat. The unit's officer, under pressure to accomplish his missions, made the sensible choice to get 9 Sturmgeschütz assault guns instead. These machines were available, dependable, and ready to work immediately. The King Tigers were shelved, sitting idle, useless monuments to wasted steel. Come mid-August 1944, as Allied armies poured across France, these 5 abandoned King Tigers had become a serious problem. German troops couldn't fix them. They didn't have the powerful recovery cranes needed to haul 70-ton vehicles. They had no replacement parts for those complicated powertrains. The call came down to blow them up instead of letting American soldiers capture them. Explosives were planted, turrets were blown clear of their rings, and the shattered remains were left scattered along French roads. Within a few days, advancing American forces began discovering these wrecked King Tigers. The first soldiers who spotted them crept forward with every weapon ready, bracing for ambush, tensing for fire from those terrifying 88mm guns. Instead, there was nothing but silence. The tanks were empty, hatches were thrown open, no crews inside. The Germans, unable to salvage or repair these iron monsters, had destroyed what they could and left the rest behind. American tank crews could barely believe their eyes. Command had warned them these machines were unstoppable. They'd been told that facing a King Tiger meant almost certain death. Yet here they sat, silent and powerless, beaten not by American firepower, but by poor German engineering. The first intact King Tiger seized by American troops became extraordinarily valuable intelligence. Technical specialists from First Army showed up with cameras, rulers, and cutting torches. Ordnance engineers joined them. British technical advisors added their knowledge. The examination took days and generated reports that spread throughout Allied command. Engineers and mechanics went over every square inch of the towering, lifeless machine. They needed to understand every detail. They had to know what it could do, what it couldn't, and how to stop it. What they uncovered astonished them. The steel plating was remarkable indeed. The turret front measured 180mm, angled at 80 degrees from straight up. The front hull was 150mm thick, sloped at 50 degrees. This armor could stop nearly every gun on American and British tanks. Shells that might have torn through a Panther just bounced harmlessly off this sloped protection. From the front, this machine was nearly unstoppable. Testing against captured steel panels proved that standard American 75mm rounds couldn't get through at any distance. Even upgraded 76mm ammunition struggled against the thick sloped plating. The main cannon was equally impressive. The 88mm KWK-43 could punch through 5 inches of steel at 2,000 meters away. This was a gun that outranged, outshot, and outperformed every Allied tank weapon. Facing another tank across open ground at long distance, the King Tiger held every advantage. The ammunition came in 2 pieces, the shell and powder charge loaded separately. This meant slower firing compared to single-piece rounds, but it allowed much higher muzzle speeds and deeper penetration. American technicians measured the barrel at 6.3 meters, more than 71 times the gun's diameter. They analyzed the breech, the recoil system, and how it mounted. Everything showed superior engineering. The optical gear particularly impressed them. German range-finding and aiming equipment represented the world's best technology. A King Tiger gunner could spot and hit targets from ranges where Allied crews could barely make out shapes. Then the engineers moved their attention to the powertrain, and clarity struck them hard. The transmission used the same basic guts as the Panther, a machine weighing 25 tons less. The gears weren't substantially tougher. The bearings weren't notably bigger. German designers had essentially shoved a medium tank transmission into a super-heavy tank and expected it to survive. The outcome was entirely predictable. When running hard, transmission parts would crack and break. Engineers found proof of this throughout the captured hull. Gear teeth showed marks from extreme stress. Bearing surfaces showed scratches and spalling. The synchronizers had worn down paper-thin. One American engineer from Detroit who studied that transmission wrote in his analysis that no major American automotive company would have signed off on that gearbox for any vehicle this heavy. The design simply lacked adequate safety margins. The engine situation was much worse still. The Maybach HL230P30 pumped out 700 horses, more than enough for the 45-ton Panther. But stuffed inside a 70-ton King Tiger, that same motor was gasping. The power relative to weight barely reached 10 horses per ton. A Sherman, carrying 30 tons with a 400-horsepower engine, beat that by more than 13 horses per ton. The King Tiger was genuinely slower than the tank it was meant to destroy. American technicians crunched numbers on fuel use based on tank size and operating distance. The figures were shocking. The King Tiger carried 860 liters in its fuel tanks. Under perfect road conditions, that meant roughly 120 kilometers before needing more fuel. Off-road driving dropped that sharply, maybe 80 to 90 kilometers. Real combat with constant turning, speeding up, and high engine strain could drain everything in under 60 kilometers. A Sherman held 660 liters and could go 200 kilometers on asphalt. The King Tiger needed 30% more fuel to cover 40% less ground. The supply situation became utterly grim. A German tank column with King Tigers needed nearly double the fuel trucks compared to the same number of American tanks. In 1944, when fuel shortages crippled Germany, this weakness turned devastating. The cooling setup couldn't handle steady heavy work. Engineers inspected radiators, cooling jackets, and fan systems. Everything was properly designed for normal running. But King Tigers never ran normally. That underpowered engine roared constantly at maximum effort, throwing off dangerous heat. The radiators simply couldn't shed heat fast enough. The coolant would heat up and boil, pressure would surge, seals would rupture, and engines would stop dead. Reports from fighting in the East backed up these findings. Soviet forces grabbed 2 King Tigers in August 1944 near Sandomierz in Poland. They shipped the tanks to Kubinka, testing grounds outside Moscow, to inspect them closely. Soviet engineers put the King Tigers through the same harsh trials they used on their own machines. The Soviet program uncovered just how serious the King Tiger's mechanical troubles really were. Even moving toward Kubinka, both tanks broke down repeatedly. The cooling couldn't keep up during hot weather operations. Engine heat climbed to dangerous levels again and again. One tank's transmission quit completely on the journey. The other's right track system needed complete replacement, and full repair proved impossible, even using spare German parts that traveled with the vehicles. At Kubinka, Soviet technicians began systematic testing. They drove the King Tigers across different ground types, noted fuel burn rates, checked top speeds, and watched how long they lasted. The findings were harsh. The tanks quit working every 10 to 15 kilometers during hot spells. The cooling system failed consistently whenever temperatures climbed above 30 degrees Celsius. Engine heat built dangerously because the transmission wasn't properly cooled and the outside air was too warm. Soviet crews fired captured German 88mm guns at the King Tiger's armor. They learned that a King Tiger's own gun could penetrate another King Tiger's turret at just 400 meters distance. The gun's power was clear, but the armor wasn't quite the impenetrable fortress the Germans claimed. The welding looked much poorer than on earlier Tiger models, though German craftsmanship was generally excellent. The final drive, connecting gearbox to tracks, showed itself as another serious weak point in both American and Soviet testing. Those gears had to transmit enormous force to move 70 tons. Under the pounding of combat driving, sharp turning, fast backing, these parts snapped repeatedly. Several captured King Tigers bore obvious damage from final drive failure. The problem ran so deep that German commanders put out warnings telling tank crews to avoid hard maneuvering that could break those final drives. American technicians put their discoveries into formal technical reports. Intelligence Bulletin No. 184, released by First Army in September 1944, contained detailed technical information about the King Tiger. Those reports reached every armored unit in the Allied forces, giving tank commanders solid facts about German strengths and weak points. The findings were striking. The King Tiger, despite its firepower in direct combat, was essentially its own adversary. Its massive bulk made maintenance a nightmare. Its weak engine crippled long-distance movement. Its complex gearbox needed constant repairs. Its overlapping suspension wheels filled with mud, and in winter freezing temperatures would lock them solid. The intelligence concluded that a King Tiger in a fixed defensive position was terrifyingly dangerous. Its gun and armor gave it overwhelming superiority. But a King Tiger moving forward, crossing rough country, pushing through hours or days of advance, would probably break down before firing a shot. The longer it traveled, the more likely breakdown became. The rougher the terrain, the more it tortured those already strained components. This changed how Americans actually fought. Rather than dreading the King Tiger as an unconquerable monster, commanders now saw it as powerful but fragile. Frontal gun battles weren't the answer. The real solution was making it move, making it attack, making it maneuver. Every kilometer traveled increased breakdown probability. Every slope it climbed burdened that engine. Every turn wore down that transmission. American commanders also discovered King Tigers couldn't cross the majority of bridges because of their weight. Regular military bridging couldn't handle them. Engineers calculated the ground pressure, and despite the broad tracks, it still pressed hard enough. Bridges built for 50 tons couldn't hold 70 tons. Rivers other German tanks easily crossed became impossible barriers. This meant King Tigers could only travel set routes, making them predictable targets for air attacks. The fuel thirst was shocking compared to Allied machines. A King Tiger burned through 190 gallons to cover just 120 kilometers on roads. Off-road consumption climbed higher, sometimes double that figure. A Sherman traveled more than 200 kilometers on the same fuel. King Tigers needed enormous supply lines, a logistics chain Germany couldn't maintain by late 1944. Perhaps most significant was the production ceiling. Germany manufactured just 492 King Tigers during the entire war. Building started in January 1944 and ran through March 1945. Just a single tank in 1943. 379 in 1944. 112 in 1945 before lines shut down. Consider that against 35,000 Panzer IVs made, 6,000 Panthers and 50,000 Shermans built by America by itself. One King Tiger consumed resources that could have produced 3 Panthers or 5 Panzer IVs. Industrial mathematics didn't favor Germany. Allied bombing campaigns significantly cut those already low production numbers. RAF Bomber Command struck the Henschel plant in Kassel repeatedly throughout 1944. Raids in September and October wrecked machine tools, stopped assembly and killed workers. Output fell from over 100 King Tigers monthly in summer 1944 down to just 30 by year's end. Every bombing run meant weeks of clearing wreckage, fixing equipment and getting workers back at their posts. Schwerer Panzer Company 501 arrived on the Eastern Front in August 1944, carrying 45 King Tigers. When they reached combat, just 8 could actually fight. 47 brand-new tanks had failed before they ever fired a shot. Fresh from the factory, these vehicles arrived at the battlefield already mechanically broken. This wasn't an army marching toward victory. This was an army watching its most advanced weapons crumble from internal decay before they could engage the enemy. The battalion had loaded these tanks onto railcars at Paderborn on August 5, 1944, beginning an 800-kilometer journey toward the southeastern Polish front. But even getting there proved to be a nightmare. King Tigers were simply too heavy for standard railway equipment. Special heavy-duty flat cars had to be brought in. Loading and unloading demanded specialized ramps that could handle the enormous weight. Weight distribution became critical. Engineers had to calculate every detail to prevent the rail cars themselves from collapsing under the strain. Several King Tigers were damaged during loading when the ramps gave way beneath them. The tank's sheer mass proved to be as much a liability as an asset. After the trains finally derailed near the Vistula River, the battalion faced a 50-kilometer road march to reach their positions. What should have been a straightforward movement became a complete catastrophe. The vehicles simply started breaking down almost immediately. Final drives began to fail, tanks ground to a halt as drive sprockets snapped under the load, then the transmission started going. Gear synchronizers shattered, bearings seized up solid, clutches burned out from the strain. Within just 2 days of marching, 37 of the 45 King Tigers had broken down completely, waiting for repairs that would never come in time. Only 8 tanks actually made it to the front lines, and they entered combat almost immediately against Soviet forces pushing to expand their bridgehead at Baranov. On August 11, 1944, these 8 King Tigers faced T-34-85s in close-range fighting near Ogandor. 3 of the German tanks were destroyed in the ambush. Soviet crews hidden in concealed positions struck the King Tigers from the side where the armor was thinner and more vulnerable. Ammunition explosions inside the turrets killed most of the crew members instantly. That battle forced the German commanders to reconsider their entire approach. German tank doctrine had always kept main gun ammunition stored in the turret for quick access by the crews. The losses at Ogandar proved how catastrophically dangerous this practice was. A hit on the turret could ignite all that ammunition in a devastating fire. After this engagement, King Tigers were retrofitted to store all main gun ammunition in racks down in the hull instead. This change reduced the total ammunition capacity from 84 rounds to 68, but it meant crew members had a much better chance of surviving a turret penetration. By March 1945, the record books told a sobering story. King Tigers were operating at only 59% readiness. That meant nearly half of every unit was broken down, waiting for repairs at any given moment. When German records were compiled on March 15, 1945, King Tigers actually showed better reliability than the Panther at 62%, but both were substantially worse than the older Panzer-Lehr at 48%. The King Tiger had gradually become more reliable than its predecessor, though still far inferior to simpler, older designs. This improvement came from hard experience and constant problem-solving. Engineers from Henschel worked directly with frontline units to find mechanical issues and fix them. Modified seals stopped oil leaks. Improved gaskets prevented coolant from escaping. The drivetrain components were strengthened to last longer under stress. A new track design with wider links distributed weight more effectively. Better driver training reduced mechanical abuse from inexperienced operators. Enhanced maintenance procedures caught developing problems before they became complete failures. By early 1945, the King Tiger had transformed into a far more dependable vehicle than the early production models had ever been. But by then, Germany couldn't maintain even this improved readiness rate. Fuel was running out. Spare parts were becoming impossible to find. Industrial capacity was collapsing under Allied bombing. The Battle of the Bulge provided the ultimate test. Kampfgruppe Piper, spearheading the German offensive in December 1944, had approximately 45 King Tigers from the 501st SS Heavy Panzer Battalion attached to the 1st SS Panzer Division. The plan called for a rapid breakthrough to seize bridges over the Meuse River, cut off American forces, and capture fuel depots to keep the offensive moving. Kampfgruppe Piper crossed into Belgium on December 16, 1944, advancing through the Losheim Gap. The force consisted of roughly 4,800 soldiers, 600 vehicles, and those attached King Tigers. The advance began well enough. American defenses were spread too thin. Initial resistance was light. Piper's columns took the town of Honsfeld and seized an American fuel dump. refueling his vehicles with captured gasoline, but mechanical problems appeared immediately. Approximately 12 King Tigers never even left the assembly area because of mechanical failures before the offensive even started. The remaining tanks accompanied Piper's advance towards Stavelot, where his force captured a bridge over the Amblève River on December 18th. From there, the drive continued toward Ligneville, a small Belgian village that would become Piper's final position. Only 6 King Tigers successfully reached Ligneville with Piper. The others had broken down along the way or been left to guard key positions at Stavelot and other locations. Tank 213 was one of those 6, commanded by SS Obersturmführer Helmut Dollinger. Dollinger's original tank had broken down, so he'd assumed command of 213, which had previously been under SS Untersturmführer Franz Faustmann. These King Tigers were positioned around Ligneville to defend against the inevitable American counterattack. Tank 213, together with Tank 221 under SS Untersturmführer Gael Cantuche, took up positions at Weremont Farm on high ground south of Ligneville. From that location, they overlooked the road from the direction of Stavelot, giving them excellent fields of fire against American forces approaching from that direction. On December 21, 1944, the American counterattack came. Task Force Moorman and Task Force Lovejoy from the 3rd Armored Division advanced up the valley with approximately 25 tanks. The King Tigers opened fire at extreme range, roughly 2,000 meters. At that distance, American tank guns couldn't respond effectively. The German tanks had overwhelming advantage. But the Americans kept pushing forward, using the terrain for protection, advancing in short rushes, slowly closing the range. The return fire intensified. An American round struck Tank 213's main gun barrel, damaging it severely so the weapon became useless. The exact circumstances remain murky. Some accounts suggest a lucky shot hit the barrel directly. Others indicate the tank took multiple hits until accumulated damage rendered the gun inoperable. Regardless of how it happened, Tank 213 was now combat ineffective. Dollinger suffered a head wound during the fighting, probably from shell fragments that had penetrated the crew compartment. He took shelter in the cellar of Weremont Farm while his crew attempted repairs. But by then, Kampfgruppe Piper's situation had become dire. Cut off from supply lines, nearly out of fuel and ammunition, surrounded by American forces pressing in from all sides, Piper had no realistic options left. On December 23rd, Piper received permission to withdraw, but withdrawal in heavy armor was impossible. The King Tigers and other vehicles had run out of fuel. Piper made the only decision available. The force would abandon all heavy equipment and withdraw on foot. Approximately 800 men escaped during the night of December 23rd into December 24th, moving cross-country through the darkness to reach German lines near One. 770 survivors eventually made it back to their parent division. Behind them at Ligneville, Piper's force abandoned 135 armored vehicles, including 6 King Tigers, 13 Panthers, 6 Panzer IVs, and over 50 half-tracks and other vehicles. Demolition teams tried to destroy the equipment, but time was running out and American forces were closing in fast. Many vehicles, including Tank 213, were captured largely intact. After the battle, American recovery teams moved through Ligneville, collecting abandoned German equipment. Tank 213 proved difficult to recover because of its position on the narrow farm road. In July 1945, the U.S. Army prepared to haul it away for scrapping, but then Jenny Jeanette Dies, who owned a local cafe, stepped in. She reportedly offered American soldiers a bottle of cognac in exchange for leaving the tank in place. Her motivation was preservation. She believed the tank should remain in Ligneville as a memorial to the village's suffering during the war. The Americans agreed. Tank 213 was moved to the village square in front of the church. It stayed there for years, gradually deteriorating in the weather, until local preservation efforts began in 1951. Parts of the damaged gun barrel were replaced using sections from abandoned Panther tanks found nearby. In 1975, the tank underwent complete restoration and fresh paint. It was then relocated to its current position outside the December 44 museum, where it remains the only King Tiger still displayed on its original battlefield anywhere in Europe. Tank 323 had an equally remarkable history. This tank also came from the 501st SS Heavy Panzer Battalion and was abandoned near Petit Coup in Belgium on December 24, 1944. Sergeant Glenn George of the 740th Tank Battalion discovered the intact tank during patrol. His unit was attached to the 82nd Airborne Division, defending the northern shoulder of the Bulge. Tank 323 was in surprisingly good condition despite being abandoned. The crew had attempted to destroy it before withdrawing, but American arrival prevented complete demolition. The tank was recovered by the 463rd Ordnance Evacuation Company and transported to Spa, Belgium, then shipped through Antwerp to the United States. Tank 323 arrived at Aberdeen Proving Ground in Maryland for detailed examination. American engineers subjected it to the same rigorous scrutiny they'd given other captured German vehicles. They measured, photographed, tested, and documented every single aspect of the machine. The tank remained at Aberdeen for approximately 40 years, displayed outdoors where rain, snow, and sun gradually deteriorated its condition. In August 1991, Tank 323 was transferred to Fort Knox, Kentucky, for display at the Patton Museum of Cavalry and Armor. To create an educational cutaway exhibit, technicians cut open the left side of the hull, exposing the interior layout, ammunition storage, and mechanical systems. This allowed museum visitors to actually see inside a King Tiger, understanding how the crew worked and how the various systems functioned together. Tank 323 later moved to Fort Benning, Georgia, where it remains in the U.S. Army Armor and Cavalry Collection. It's the only intact King Tiger captured by American forces during World War II. The psychological impact on German tank crews was devastating. These men had been promised an invincible war machine that would restore German dominance on the battlefield. Instead, they received a mechanical liability that broke down constantly, consumed fuel at catastrophic rates, and required specialized recovery equipment that rarely existed. The gap between the propaganda and the reality destroyed morale, even among veteran crews. For American tankers, the shift in understanding was dramatic. In July 1944, just the mention of a King Tiger caused genuine fear. Intelligence briefings described it as nearly unstoppable. Reports from British units painted it as practically invincible. Every rumor made it more terrifying. By December 1944, during the Battle of the Bulge, American crews had learned the truth. Yes, the King Tiger was dangerous in direct combat, but it was far more likely to be out of fuel, broken down, or abandoned by its own crew due to mechanical failure than to be destroyed by Allied fire. The invincible monster had been revealed as a deeply flawed system. American after-action reports from the Bulge noted that more King Tigers were found abandoned because of mechanical failure or fuel exhaustion than were actually destroyed by Allied weapons. Tank crews reported discovering King Tigers beside roads with broken tracks, seized engines, or failed transmissions. Some had been abandoned with only minor damage that would have been repaired quickly on more reliable vehicles. But the King Tiger's complexity made field repairs nearly impossible without specialized tools, rare parts, and highly trained technicians. Technical interrogations of captured German tank crews revealed how deep the problems went. Drivers reported that the gearbox demanded constant, careful shifting to avoid damage. Any aggressive maneuvering, any emergency situation requiring rapid speed changes risked transmission failure. Commanders revealed they could never rely on their tanks to complete long-distance movements. Every march had to factor in breakdowns and recovery operations. Maintenance personnel explained that repairing a King Tiger demanded specialized tools, hard-to-find parts, and skilled technicians. A broken track on a Sherman could be fixed by the crew in an hour using basic tools and manpower. A broken track on a King Tiger, with its overlapping road wheels and complex suspension, could require a full day with specialized equipment. The overlapping wheel design meant that replacing an inner wheel required removing multiple outer wheels first. In winter, mud and ice froze between the wheels, making maintenance nearly impossible in field conditions. A failed transmission meant complete replacement, a job requiring heavy lifting equipment and multiple days of work. The transmission weighed more than half a ton. Removing it required specialized jacks and hoists. Installing the replacement demanded precise alignment and careful adjustment. Most field maintenance units lacked the equipment and expertise for this work. A King Tiger with transmission failure usually had to be towed to a rear area workshop, assuming a recovery vehicle capable of moving 70 tons was available. The final lesson came from production statistics that told the story of industrial capacity determining victory. Germany's industrial resources that could produce 3 medium tanks went into making 1 King Tiger. America built 11 Shermans in the same time with similar resources. For every King Tiger Germany fielded, America fielded 11 Shermans, all of them more reliable, easier to maintain, and actually capable of reaching the battlefield. American factories produced tanks at rates Germany simply could not match. The Chrysler Tank Arsenal in Detroit, Michigan, built over 18,000 Sherman tanks between 1942 and 1945. A single American factory produced more tanks than all German King Tiger production combined. Ford Motor Company built over 1,000 Sherman tanks per month at peak production. General Motors, American Locomotive Company, and other manufacturers added tens of thousands more. This production advantage extended far beyond raw numbers. American factories could replace losses rapidly. A destroyed Sherman could be replaced in weeks. A destroyed King Tiger could not be replaced at all in the war's final months as production collapsed completely. American logistics could deliver replacement tanks to frontline units efficiently. German logistics struggled just to deliver fuel to existing tanks, let alone replacement vehicles. The Americans who captured and studied these machines took away lessons that shaped post-war tank development for decades. They learned the value of reliability over raw power, simplicity over sophistication, sustainability over capability. These principles guided American armored vehicle design long into the future. The M48, M60, and M1 Abrams all prioritized reliability and maintainability as core design requirements, lessons hard-earned from examining German over-engineering. American tank designers recognized fundamental truths. The most powerful gun was worthless if the tank couldn't reach the battlefield. The thickest armor provided no protection if the tank broke down before encountering the enemy. The most advanced technology meant nothing if field mechanics couldn't maintain it. These lessons learned from studying the King Tiger's failures became bedrock principles of American military vehicle design. The King Tiger remains famous today, featured in films, video games, and popular culture as the ultimate German tank. That reputation is based partly on reality. In direct combat, properly positioned and adequately supplied, the King Tiger was indeed formidable. British tanker Ken Jolly, who fought in Normandy, described encountering a King Tiger as truly terrifying. The massive size, the thick armor, the powerful gun all combined to create a weapon that dominated any engagement where it could be brought effectively to bear. But that scenario represented only a tiny fraction of actual warfare. The far more common scenario was the one those first tanks experienced in July 1944. Long marches, mechanical stress, inadequate logistics, inevitable breakdown. Of the 492 King Tigers produced, the vast majority were lost to mechanical failure, fuel exhaustion, or abandonment rather than combat destruction. This was not the weapon that changed the war. This was a weapon that symbolized Germany's fundamental inability to match Allied industrial power. For the American soldiers who discovered those first abandoned King Tigers in summer 1944, the experience was transformative. They had feared German technological superiority. They had worried that they were outmatched. Then they found the reality. The most advanced German tank could not complete an 80-kilometer road march without catastrophic mechanical failure. The invincible superweapon could not reach the battlefield under its own power. Germany's fate became obvious. A nation that could not build reliable tanks could not fuel its armies. It could not maintain its equipment. It could not win a war of industrial attrition against the combined might of America, Britain, and the Soviet Union. The broken King Tigers proved it beyond doubt. Those abandoned tanks served as powerful symbols of what had really happened. American industrial might and mechanical reliability had defeated German technological sophistication. The war would be won not by who had the best tank, but by who had the most tanks that actually worked. That lesson, paid for in blood across multiple continents, would shape military thinking for generations. The King Tiger's true legacy was not its brief moments of combat effectiveness. It was the demonstration that sophisticated engineering without reliable execution was ultimately worthless. That was the real story.